Hello everyone and welcome to Calculus. This is area between curves, but part 2. So the first 12 problems are on the first video, but picking up where we left off. Number 13, find the area of the region between the graphs of f of x is equal to 3x cubed minus x squared minus 10x, and g of x is equal to negative x squared plus 2x. Do not use a calculator. So just to make sure that we practice a few without our calculator, some graphing practice here. I know this is a cubic function. I know that it ends up, and I know it has a y-intercept of 0. So to find the x-intercepts, I'm going to factor. So I take out the x first. That gives me 3x squared minus x minus 10. And then I factor first the 3x and the x, and then I need a 5 and a 2. That'll give me the 1 that I need. I want the minus to be with the 6. So my zeros are 0, 0, negative 5 thirds will make a 0, and 2 will make a 0. For my other graph, g of x, I know it's a downward parabola. And it also has a y-intercept of 0, 0. And to find my x-intercepts, I can factor. I'm going to factor out the negative. I personally think that always makes the problem easier, although this one's already pretty easy. So 0, 0, and 2, 0. So already I see 2 points of intersection. So I'm going to go ahead and make my graph. And let's see, I'll make the parabola first. 1, 2, 3, 4, 5, 1, 2, 3, 4. Hope you're making the graph as well and not just waiting for me to do it. So 0, 0, 2, 0, and this is a downward parabola. And then my cubic function, negative 5 thirds, which is the same as negative 1 and 2 thirds, and 0 and 2. And it's cubic, so it goes up and then down and then up again. So I see the region that I want, and I can highlight it there. And I can find that integral. It's very straightforward. It's going to be the top curve, which in this case is the blue one, which is our parabola, negative x squared plus 2x, minus the bottom one, which is our cubic function, f of x. So of course you do have to remember these parentheses, otherwise you would forget to distribute the negative. And we get from that negative, I'm also going to put it in descending order. This is plus x squared, which this minus x squared actually cancels, and it's plus 10x, and then plus 2x makes plus 12x. And I'm going from 0 to 2. When I do that, I integrate, I get negative 3x to the 4th over 4 plus 12x squared over 2, which ends up being 6x squared. And I'm going to go from 0 to 2. When I put a 2 in here, I get 16, which divided by 4 is 4 times negative 3 is negative 12. When I put a 2 in here, I get x squared, which is 4 times 6 is 24. And my final answer looks like it's 12. You do have to plug in the 0, but I can do that in my head. It's not always 0 when you plug in a 0, especially with things like cosine. But in this case, plugging in 0 works. But more importantly, go back and look at our graph. We're actually missing something. Find the area of the region between the graphs. So I was very deliberate in how I graphed it. I did what I thought most kids would do, which is to just graph the part that they can see on a 5 by 5 graph. However, these two graphs will intersect again. So if this one keeps going down at the rate that it's going, and this one, the parabola, which is not growing not going down as fast, they will eventually intersect again. So this area that I found only represents this area right here. There's a whole nother area right here, and we need to find that. So then the question is, what is this point of intersection? So how do we always find a point of intersection? We solve the equation. So 3x cubed minus x squared minus 10x is equal to negative x squared plus 2x. I already know 2 of the 3 answers to this equation. I know that they intersect at 0 and at 2, but I need to find this last one. So I'm going to set it equal to 0. These cancel from both sides, and then I have minus 12x. Does that look familiar? Right up there. Oop, that's a cube. And I can take the 3x out, which gives me x squared minus 4 is equal to 0. And my answers are 0 plus or minus 2. So this is the point negative 2. We already found the plus 2 and the 0. I can plug the negative 2 into either equation because they share the point. So of course I'm going to use the parabola because it's easier. It looks easier, but remember that it might not be, because sometimes people do this negative wrong. Negative 2 squared, these negatives do not cancel. Instead, exponents come first. So negative 2 squared is 4, and then the negative. So this is actually negative 4 minus 4 is negative 8. So to get the green area, I need the integral from negative 2 to 0. Remember, always go from left to right on your graph. And this time, the green is on top. So it's going to be 3x cubed minus x squared minus 10x minus the parabola, which is negative x squared plus 2x. So this should produce the opposite answer that we got before, but we can quick check that. Oops, negative 2 is on the bottom. Negative 2 to 0. So sure enough, 3x cubed in descending order. This becomes plus, which cancels. This becomes negative, which is minus 12x. So it is the same as this one, but times negative 1. So if I can trust that I did the integral right the first time, then I can just reuse my answer, 6x squared, this time from negative 2 to 0. But be careful. When you plug a 0 in, you do get 0, but then it's 0 minus the next answer. So you can't just plug in the negative 2. You have to remember it's 0 minus that answer. Plugging in a negative 2 should produce the same answer because this is even. Both of these are squared or to an even power. This one's to the 4th. So whether you plug in 2 or negative 2 should produce the same answer, which was 12. So I get negative 12 for my answer, which is 12 for the green area. And if I put those two together, then my final answer is 24. So it's easy to miss that green section. Always make sure you draw a complete graph. Number 14. Find the area of the region enclosed by y is equal to x to the 4th minus 2x squared and y is equal to 2x squared. So the answer is 128 over 15. If you would like to try this by hand, you could try graphing it yourself, doing the integral yourself. But of course, you do know I'm going to do it for you. 1, 2, 3, 4, 5. I always start with a graph. I know that this is some kind of a quartic function that ends up, and I know that it has x squared as a repeated 0, and then x squared minus 2. So its zeros are at 2, if I set this equal to 0, at 0, and plus or minus the square root of 2, which is about 1.4. So somewhere right there, and 0. It is an even function, so I know that it looks like this. Don't make that pointy there in the middle, make it curved. That's what it looks like. And then my other one is just a parabola that's a little bit steep, and it also has a bounce at x squared, but it's going up. So now this is important. If you just draw it like this, and you make these two lines parallel, it might look like they're never going to cross, but they do cross. I'm not saying they cross where I'm going to draw it. I'm going to draw it a little extra wide because I didn't go very high on my picture. Just because I want to know, I want you to see that at some point I can see that they're going to cross. So I'm going to find the area of this region right here. So I need to know those points of intersection. I find the points of intersection by doing x to the fourth minus 2x squared is equal to 2x squared. It's possible that if I had graphed the green one really nicely, actually like made a table and plot, I could have found the points where they intersected. But I'm always just about making a rough sketch. I just want to have an idea of what I'm looking at, and I have to know which one's on top. So it's definitely going to go, which by the way, if you're allowed to plug this into your calculator and you're not required to do it by hand, instead, I would probably label this y1 and label this one y2, and then just simply write y1 minus, oh, actually the green one's on top, y2 minus y1, y2 minus y1. So if you're not required to do the workout anyway, this is acceptable. So I am going to find this point of intersection. So I set it equal to 0, x to the fourth minus 4x squared is equal to 0. Factor out the x squared, and I get x squared minus 4 is equal to 0. X is equal to 0 plus or minus 2. So this is the point 2 comma something. When I plug in a 2, I get 8, which of course I did not graph it all accurately, which is fine. Positive 2, 8. So I could go from negative 2 to 2, and even though it stops, because the green graph is always on top of the blue graph, I could do that. However, if you're going to do this by hand, which we are, that means at the end you're going to be plugging in a negative, which people tend to do wrong. So as another idea, you could get rid of this negative 2 and multiply your answer by 2. Because this is an even, they're both even functions, the two regions are the same size. So we're going to do this one a little bit differently. We're going to go from 0 to 2, and we're going to multiply our answer by 2. So 2 integral from 0 to 2, zeros are just always easier to plug in, of 2x squared minus x to the fourth minus 2x squared gives me 2 times the integral from 0 to 2 of 4x squared minus x to the fourth. You could have put it in descending order. I do need my dx there. And that gives me 2 times 4x cubed over 3 minus x to the fifth over 5 from 0 to 2. Okay, x to the third and x to the fifth. I'm definitely happy I don't have to plug in a negative 2. Plugging in the 0 will definitely produce a 0. 2 cubed is 8. 8 times 4 is 32 thirds. 2 to the fifth is also 32, but fifths, so not really that handy. I need to get a common denominator, which is going to be 15. So 32 times 5 is 160. 32 times 3 is going to be 96. And 160 minus 96 is equal to 64 times 2 is 128/15, which of course was the answer. All right, let's do 15. So these last few really step it up a notch. And so if you're looking for something especially challenging, here we go. Find the area of the region in the first quadrant bounded on the left by the y-axis. So I really only need to draw the first quadrant here. 1, 2, 3, 4. Bounded on the left by the y-axis and below by the line y is equal to x over 4. So it goes through 0 and then up 1 over 4 is its slope. So that is going to be the bottom boundary. It's bounded above and on the left by the curve 1 plus the square root of x. So I move that up 1, but then square roots are 0, 0, 1, 1, 4, 2, which is up 1. So that's going to be my red curve. And above right by y is equal to 2 over the square root of x. So I actually don't know what 2 over the square root of x looks like. So I'm gonna have to plot points. So x can't be 0. I know it's undefined at 0. I know at 1 it's 2. Well, that's good. There's a matching point. I know that I'm not going to do 2 because I don't know the square root of 2. I know that at 4 it's 1. I know that at 4 it's 1. And since it has an asymptote here at 0, and it also never has any x-intercept, I can be pretty sure it goes like that. So again, I know it has a vertical asymptote because x can't be 0, so there must be a vertical asymptote there, which means it kind of goes along that. So here's my region. Remember, first quadrant only. And I am going to have to break it down into 2 parts. So right there, the graph is going to change. So for the first part, it's going to be the red graph. Let's give these names. So this is 1, 2, 3. So in that first section, y2 is on top, and the blue one, y1 is on bottom. And then for the next section, the green graph, so you really couldn't have done this without graphing. Y is equal to, or y3 minus y1 again. I do need to find the points of intersection, although in this case, I made such a good graph. I was trying to be so careful. I actually know them. So this one's going to go from 0 to 1, and then from 1 to 4. So of course, if you want to practice this by hand, you can, but I'm just going to go ahead and give you the answer, which is 11/3, because there's no reason why you couldn't just type this into your calculator. What made this one interesting was, of course, the complicated graph. All right, number 16. Suppose the area of the region between the graph of the positive continuous function f and the x-axis from a to b is 4 square units. So I've got some kind of graph, f of x, and I know that from a to b, this area of this region right here is 4. Find the area between the curves y is equal to f of x and y is equal to 2 times f of x. So I'm literally going to double every spot on this curve. So if I'm at 2, now I'm at 4. So I'm going to try and make it twice as tall. And I'm going to call that 2f of x. So the question is, what is the area between the curves from A to B? This region right here. That's the region that we're looking for. Find the area between the curves. Got an intuitive sense of it? So the answer is going to be 4. So if intuitively you said, well, if it's twice as tall, then the whole area is 8. And then if you subtract the original 4, you were right. But if you had to show your work for it, it's actually not that bad a problem. So it would be the integral from a to b of 2f of x minus f of x, which would be the integral of a to b of 1 f of x. And we've already learned that the integral from a to b is 4. Another way you could think about it is if you did the integral separately, so from a to b of 2 f of x would be the whole entire region, and then stop the integral. I'm really bad with my dx's, so sorry. Minus the integral of just f of x, the green region, from a to b. Then you could move this 2 to the outside, and then you would have 2 times, and this integral is 4, minus this integral, which is 4, and that would still give you 4. So this is more of a thinking question. This might be something that on the AP exam you would see as a multiple choice question that they expected you to do quickly just by thinking about it. Number 17, find the positive value of k such that the area of the region enclosed between the graph of y is equal to k cosine of x and the graph of y is equal to kx squared is 2. So again, another thinking question here. So how does k affect cosine? It just makes it taller when it's because it's positive value of k. Otherwise, it would also flip it. So cosine normally just starts at 1 and it goes down. That was terrible. Cosine goes down and it comes back up again like that. So depending on what k is, that would determine how tall it is. So this is the point 0, comma k. And then the graph of y is equal to kx squared, that graph is going to be just a parabola, and that k is going to determine how steep it is. So I'm going to draw a basic parabola. Y is equal to kx squared. So the question is, where do these graphs intersect? I need to know the point of intersection in order to do the problem. But fortunately, as long as I'm multiplying both functions by k, the point of intersection will not change. Here's why. You're trying to figure out where k cosine of x is equal to kx squared. Well, I can get rid of the k. It's just wherever cosine of x is equal to x squared. I can divide both sides by k. So the point of intersection will always remain the same, because if the cosine graph gets taller and this gets steeper, then, so I don't know if I can quite draw that, but if the cosine graph gets taller, but then this also gets steeper, do you see how the point of intersection will continue to line up? So the bottom line is we just need to find that point of intersection. I really can't solve this equation. So what needs to be your go-to? Your calculator. So I go to my y is equal to, and I type in our two functions. I always check my mode to make sure that I'm in radians. In calculus, everything's in radians. And then I go to my graph. It's exactly as we had expected, and I need to find that point of intersection. So I use second calculate. Number 5 is intersect. There's only 2 curves, so you can go very quickly. First curve, second curve. If you want to get the right-hand point of intersection, move the cursor over just a little bit when it guesses so that it'll guess on the right. And I get 0.8241323. So I'm going to go ahead and write down that point of intersection. I'll use my original graph there. It is 0.8241323. I didn't actually bother to even get the y coordinate. It doesn't really matter. On my integral, I know that I just need to write it here. Now, if you're taking the AP exam and you write that this is A, comma, B, and then you just put A here, that's allowed. You don't have to rewrite the entire number. In fact, you're probably better off not rewriting it on the outside chance you write a decimal place, one of the places wrong. So I hope that you can see that this is an even function. Cosine is even, and of course, x squared, not having been moved left or right, is even. So it's also going from negative a to a. But remember the trick that we learned and did just a few problems ago, or you can multiply by 2 and go from 0 to a. So you have a few choices there. And of course, the red, well, it's hard to see because I have more than one graph on there. So actually, we don't want the red ones at all. But if you look at the black and the blue one, the black one is on top, which is our cosine graph. So k cosine of x minus, and then our parabola is on bottom, kx squared dx. Look at me go, I remembered my dx. So of course, the question is still, how do you possibly do that? Well, if you take out the k, then you can do this little piece on your calculator. You literally can type it in just, well, not with an A. You would use the letter X here, use X on your calculator, and your calculator will remember that value. I'm not going to go back and do that for you. We've done plenty of integration. But from 0 to x of cosine of x minus x squared, use Math 9. And it tells you that this region enclosed is 2. So now we have 2k, and using our calculator to do all of this, this comes out to 0.54737 is equal to 2. If you want, you can divide both sides by 2, or you can multiply 2 times the 0.54737 first. But at any rate, you will get k is equal to 1.8269, which, of course, you only have to do 3 decimal places, so 1.827. There you go. Okay, last one. This is a hard one, so let's go ahead and start by making the graph, which is something we do know how to do. It is a rational function, so first I think about asymptotes. Its horizontal asymptote, the power of the numerator is smaller than the power of the denominator, so it's going to have a horizontal asymptote at 0. And since the bottom is never equal to 0, it's going to have no vertical asymptotes. The y-intercept is going to be 0. And that wasn't very much information. So when in doubt, make a table. All I know is that its end behavior is going to be following this asymptote. So I start with 1. If I plug in a 1, I get 1/2. If I plug in a 2, I get 2/5. I can definitely see the pattern here. If I plug in 3, I get 3/10. So it's clearly getting smaller, which makes sense because it's following that asymptote. But if I plug in a -1, the bottom is still the same because it's being squared, but the top changes to a negative. So I would have -1/2, and then -2 would be -2/5. So this is an odd function. And then -3 would be -3/10. So I'm going to go ahead and plot those points so I can have an idea of what it looks like. At 1, it's 1/2. At 2, it's a little bit less than that, and then less than that. But at -1, it's -1/2, and then less than that, and then less than that. So it must look something like this. Which is a very cool looking graph, not one that we've studied. And now I have some kind of a line. And it makes sense now why the slope had to be less than 1. If the slope was greater than 1, it's possible it wouldn't have even intersected with it. But let's go ahead and draw our line. So I don't know exactly what m is, so I personally am going to go through this point just to try and make it look, oh, that wouldn't be right, just to try and make it look even. So if I go through that one, then I'd want to also go through that one. And now I can see my region that's enclosed. Like I said, that line could shift, but at least now I'm getting this little region right here. There's 2 of them. They are going to be the same. So find the area. 2 from 0 to, so what is that point of intersection? All right, here comes the hardest part of this problem. Actually, this whole problem is hard. But to find the point of intersection, I'm going to have to set x over x squared plus 1 equal to mx. But it's not a number. So the question is, can we do the math anyway? Well, we have to. So I am going to clear the fraction, multiply both sides by x squared plus 1, which gives me mx cubed plus mx. So I'm going to set it equal to 0, and I get mx cubed plus mx minus x. I can factor out first, which gives me mx squared plus m minus 1. So either x is equal to 0 or mx squared plus m minus 1 is equal to 0. And at first glance, you might be thinking, well, I can't factor that, and am I going to have to do quadratic on it? But no, because this is just an x squared. There's no x term. So you can literally just do is equal to 1 minus m. I brought both of those over to the other side. Divide by m, and then plus or minus the square root of 1 minus m over m. So that's what this x value must be, plus the square root of 1 minus m over m, which also explains why m is less than 1. Otherwise, you would have a negative underneath the radical. Comma, who cares? It doesn't even matter what the y-coordinate is. You just need to be able to get from 0 to that really exciting value. Which curve is on top? The x over x squared plus 1 curve is on top, and then the mx is on the bottom. Dx. This is still a hard problem because I still have a hard integral. So in order to do this integral, I'm going to let u be x squared plus 1, which would mean that du is equal to 2x dx. So x squared plus 1 would be inconvenient for this one. So I'm going to break it up into 2 separate integrals so that I can do the calculation. So x over x squared plus 1 dx minus, and I can keep that 2 with it, mx dx. That way I can use the u just on this part and not make a mistake. So this becomes temporarily 2, and then I have the 2. I have exactly the 2 that I need. So this is just going to be du over u, which becomes the natural log. Oops, I've already taken the integral. This becomes the natural log of x squared plus 1. And then this one over here was much easier. It's going to become mx squared over 2, but then since I have a 2, that 2 is going to go away. Mx squared over 2, but then with that 2, it's just going to become minus mx squared. From all of this from 0 to the square root of 1 minus m over m, which looks terrible, but luckily both of the x's are squared, so it's not as bad as it looks. This is going to be the natural log of x squared, so 1 minus m over m plus 1 minus m times x squared, which is 1 minus m over m. Now be careful. It's really easy to think that you're done. You're like, oh, good, and a 0 on the bottom, which does make this 0. But what about the other one? If you plug a 0 into here, you still get a 1. So x squared plus 1 is 1, or 0 squared plus 1 is 1, but you would have gotten lucky. The natural log of 1 is 0, so it would have been minus 0. We are going to simplify this just a little bit. The natural log, let's change this to m over m to give it a common denominator. And if we do that, 1 minus m plus m is just 1 over m. And then these m's cancel, and I distribute my negative, so minus 1 plus m. You could leave it that way, but the natural log of 1 over m is the natural log of 1 minus the natural log of m. And I can get rid of my absolute value because they said that m was greater than 0, so I don't actually need that anymore. And then the natural log of 1 is 0. So this entire thing just becomes negative natural log of m minus 1 plus m, which is unbelievably the answer. So this one was super challenging. Great way to end it. Have a good day.